Welcome back. My name is Mwiza Chirwa. I'll be taking you through part 4 on the same topic that we started looking at, that is hydrocarbon, the topic from Form 2. So let us look at which success criteria are we going to achieve by the end of this lesson. So by the end of the lesson, we should be able to state the uses of alkanes, name and draw the formulae of alkanes up to 10 carbons. So this is what we're going to be discussing in this lesson. So feel free to interact and follow what we are going to look at, and we should be able to achieve the objective that has been stated here in this slide. So let us start by looking at the uses of alkanes. Remember, so far we have covered a lot in alkanes. Now we should be able to look at the uses of alkanes, the impact to our life as well. So the first use of alkane, it is a source of fuel. It's a source of fuel. So for example, we have methane. Methane is a natural gas which is used for heating, cooking, as well as electric generation. So we can use methane gas to generate electricity. We can use methane gas for cooking in stove. We can use methane gas for heating. It is also used as fuel in vehicles, in some cars, as a substitute of petrol. So the methane gas can also be used to drive machines, usually the engine from the car. That's why it can work as a substitute of petrol in some of the cars. So the other one is propane. Propane is used for heating, cooking, as well as fuel for engines. In the same purpose, since it's an alkane, it can also be used for heating, cooking, as well as for fuel, for substitute for petrol in car engines. Butane. Remember, we're looking at some of the possible members of alkanes. So butane is also a member of an alkane. It is an alkane. So butane can be used in lighters as well as a fuel for portable stoves. So remember, in homes we have some stoves that we use for cooking. The gas which can be used apart from the gases that we have discussed so far, as methane as well as propane, butane also can be used in those stoves, which will be used for cooking as a fuel. It can also be used for lighters to produce light. Another alkane that we can use for such work is gasoline. So when we talk about gasoline, it's blood. So gasoline is a mixture of alkanes such as heptane, tetraethyl lead, which powers internal combustion in engines of the car. So in short, this gasoline is used as a fuel in car engines. So gasoline is just a broad term, but it involves a mixture of alkanes such as heptane as well as tetraethyl lead, which is used to power combustion reaction in the car engine. Remember, to drive the engine, there is a combustion reaction. So that's why we're saying that there will be internal combustion in car engines, so in order to drive the vehicle, the engine of the vehicle. So propane, propane and butane, which are components of liquefied petroleum gas. So liquefied petroleum gas is used in school laboratories. For example, here let us look at the diagram. This is a gas cylinder which is inserted in a gas cylinders, which a Bunsen burner, which we use in laboratory. So for it to produce light, it uses the gases such as the propane and butane, which forms a liquefied petroleum gas. So a liquefied petroleum gas comprises of propane and butane. So they are enclosed in a cylinder which is inserted in a Bunsen burner to produce heat, which is used for heating. So this is a setup of our gas cylinder comprising of liquefied petroleum gas, which has a component of propane and butane. Butane mixed with small proportion of propane are compressed in a gas cylinder and used in household lighting. So it can also be used in household lighting. Another use of alkane is like it is used as lubricant. So if I may take you back in the Form 1, where we looked at the components of crude oil, one of the component is bitumen. So bitumen is an alkane. So that alkane it's used for making tarmac, which is used to lubricate the roads. So that's why we're saying that it is used for lubrication. So higher alkanes are used in production of lubricants oil. This oil helps to reduce friction and wear in machinery and engines. So which lubricant oils are we talking about here? We are talking about grease. We're also talking about the actual oil which is used in cars. Apart from that, we have said that we can also make the bitumen, which is also a component of crude oil. It's an alkane which can be used to surface the roads as tarmac. Another use of an alkanes is it is used as a solvent. So alkanes like hexane and heptane are used as solvent in various industrial processes and for extracting of substance in the lab. Apart from that, if we look into our daily processes, if we go to painting, usually for us to dilute paint, which we use to paint buildings as well as our house, we use paraffin to dilute the paint. So the paraffin is the one which is an alkane, and the work that it uses to dilute, so it works as a solvent. It is also used as aerosol propellant. Certain alkanes such as butane, propane are used as propellants in aerosol spray. For example, if we are talking about aerosol spray, we are looking at, for example, if you see how cars are being painted, they use a spray. So we're talking about such spray. So in such spray, for it to operate properly, we use butane as well as propane. It helps to deliver the product from the container. So for example, in that bottle where you have a paint, where you want to paint your car, you need to have butane as well as propane in order just to help to deliver the product to the surface where you are painting. They are also used as cosmetics and personal care products. This is common. For example, if we go to shops, we'll buy different lotions as well as creams as well as perfume. They can be produced from alkanes. For example, if you have Vaseline is prepared from the butane, and it can be used to apply in the body, and they produce good smell to people, and they improve the surface of the body as well as it nourish the body. So it is used in cosmetics, provided that they are able to make cream, lotion, as well as some body care such as Vaseline. So it can also be used in industrial processes. Alkanes are involved in various industrial processes, including production of synthetic fibers, rubber, and other materials. So rubber is also alkane is also used in production of rubber industry. Now, we have covered on the uses of alkanes. We have talked much about the uses of alkanes. If we were just to make summary of what we have discussed, we have talked about that they are used in home-based for cooking, lighting, It's used in lab as well as for heating. It is used to generate electricity. For example, methane, natural gas. It is used to drive engine of the car, so it is used as fuel. It is used to make cosmetics as well as perfume, such as Vaseline. Um, they are used to propellant in aerosol, where they help to release the product properly. Now we are done with the alkanes. We'll shift our concentration to alkenes. So remember last time we said in terms of classes of hydrocarbons, we have alkanes and alkenes. So the last one for this section would be alkenes. So alkenes are also a class of hydrocarbons. They are also known as olefins. So another name of alkene is olefins. They have a carbon-to-carbon double bond. So it means in an alkene we expect to have a functional group. Remember, in an alkane we don't have a functional group. So if we were to differentiate between alkenes and alkanes, it means now alkanes have a double bond between carbon to carbon, and in alkanes we always find a single bond throughout the carbon chain. So the double bond is formed as a result of two carbon atoms sharing two pairs of electrons. So here, let us go in this bracket. We have two carbon atoms here. So if we have, remember, if we have one bonding line here, this one tells us that each of the atoms are sharing one electron. Remember, here we have a covalent bond. So if you have two, it means each atom is sharing two electrons at the area of intersect. That's why here we have two hyphens, which are indicating as double bonds. So this double bond introduces a degree of unsaturation. Remember, we differentiated between saturated compounds as well as unsaturated compounds. In short, we can say that alkenes are unsaturated. What makes an alkene to be unsaturated? Because of the presence of the double bond within the molecule. So alkenes, what will be the impact of that double bond in alkenes? So the double bond present in alkene makes alkenes to be more reactive. Remember, we said alkenes are less reactive because they form strong carbon to carbon and carbon to hydrogen single bonds. While alkenes, since they have a double bond somewhere else, alkenes are very reactive. So if you are asked to identify between alkane and an alkene, which one is more reactive? Alkene is more reactive. The reason why it is more reactive, it's because it has a single double bond within the carbon chain, or you can say they are unsaturated molecules. Okay, so what makes the double bond, makes alkene to be more reactive? We have said this presence of the double bond. So what happens? During chemical reaction, since they are very reactive, during chemical reaction, the double bond breaks. Usually here, if we have the double bond as well, we can see from the bracket here, the second bond here is much weaker to compare with the first one. So during chemical reaction, this bond usually breaks. And if it breaks, it allows other atoms or groups of atoms to join in the molecule. This makes alkenes to be more reactive. Unlike alkanes, if they are to react, they are supposed to subject it to specific conditions, and some of the reaction that they can undergo, it will be substitution reaction where more reactive atoms will substitute the hydrogen in an alkane. Well, that one is different from an alkene since it has a double bond. and the second bond here is much weaker to compare with the first one. So you just need little amount of energy to break this. As it breaks this one, it means now the carbons which were close to the double bond, they have a deficit of electrons. Therefore, they will get attached to other atoms or groups of atoms in order to make them stable. General formula and the functional group of alkenes. Remember, in previous lessons we defined the meaning of general formula as well as the functional group. If we look at the functional group, just a recap of what we discussed. We said the functional group is either a bond, a single atom, or groups of atoms which determine the chemical properties of the molecule, chemical and physical property of the molecule. While a general formula is an arithmetic expression which shows the relationships between variables. So that is how we define these two terms. Now let us go into details now. We said alkenes have both general formula and functional group. While in alkenes we only have the general formula, we don't have a functional group. So the general formula of alkene now changes. It is CnH2n. If you can check, it is different from the one which we used in alkenes. Here there is no plus 2 here. Why have we omitted or removed plus 2? Because there will be a double bond along the molecule. So if you have a double bond, it means we are going to remove 2 hydrogens, where the n represents number of carbons. So we can work out in each and every alkene that we want using this general formula. Usually the general formula tells the relationship between number of carbons and hydrogen. That's why the definition of general formula, it says that it's an arithmetic expression like this one, which determine the relationship between variables. So the variables that we are going to show the relationship is between carbon and hydrogen atoms here. So using the general formula, we can work out each and any alkene that we want of interest, depending on the number of, if we are given the number of carbon as well as number of hydrogen, we can work and identify the alkene. So the first alkene now is ethene. But in alkene, we said the first alkene is methane. The reason why we don't have methane is that methane only has, it means it is supposed to have one or single carbon. So we can't put a double bond in methane. That's why we don't have methane. The first alkene is ethene, where we can have a double bond. Each member of alkene in the homologous series has 2 hydrogen less than the corresponding alkene. What do we mean? For example, here, if we have the chemical formula of ethene is this one, C2H4, we have 2 carbon and 4 hydrogens. Alkene here we have ethane, we have C2H6. Here we have 2 carbons and hydrogen, 6 hydrogen atoms. So we are saying that the difference between these corresponding alkenes and alkenes is that there will be a deficit of 2 hydrogen from an alkene. A deficit of 2 hydrogen comes in because an alkene has a double bond along the molecule. Structural formula of ethene and ethane. If we are to look at the structural formula of ethene and the ethane, let us check properly. This is ethane. So in ethane, you see we don't have a double bond. We just have single bonds throughout, and each carbon atom is bonded to at least 3 carbon atoms. So remember, carbon, for it to be stable, is supposed to gain 4 electrons. So since these similar atoms, they are going to share electrons. So here we are going to have 6 electrons here. Or here in ethene we have 4 electrons. We have 4 electrons here because of introduction of this double bond, which limit the carbon to only have 4 bonds. So an alkene has a functional group of carbon to carbon double bond. So this functional group is the one which determines the physical and chemical properties of the alkene. The functional groups makes the alkene to be more reactive, such that during chemical reaction the bond may break and allow other atoms to join. Naming of alkenes. Naming of alkenes. We'll still use similar procedures in naming of alkenes. When naming alkenes, we add suffix. A suffix, remember, a suffix is a part of ending. We are going to use ene to the prefix. Not all members of alkenes have the same suffix. Similar to an alkane, all members of alkane have similar suffix, but they have different prefix depending on the number of carbons. So what changes the prefix is the number of carbons. Remember, we use Greek prefix in naming the numbers. So when coming up with a prefix, we consider number of carbons of atoms in a molecule and relate it to Greek prefix of naming, except on ethene. However, the easiest method we can use to name alkenes is by replacing A in corresponding alkane. For example, if we have methane, we're going to remove A on meth and put E to form methane. When naming, we also consider position of the functional group. Now, this one becomes different from what we covered in an alkane. Since this one has a functional group, in the name we also have to consider the position of the functional group. This one helps us when we are coming up with the structural formula. For example, ethane gives ethene. We have eliminated this A and put E. Propane becomes propene. Butane gives butene. Pentane gives you pentene. Hexane gives you hexene. And the names of alkenes end with ene. So table below shows the molecular structure as well as the skeletal formula and condensed formula of alkenes. So as we covered it earlier on in alkenes, there is no much different. We still use the same criteria, but we are very careful when we insert the double bond. In both structural as well as condensed formula, as well as skeletal formula, we're supposed to show the presence of the double bond. So that's why if we have here ethene, we have a double bond here. In condensed formula, we still have this one. How do we come up with the condensed formula? Remember, we only consider the number of atoms at each carbon. So for example, this is the first carbon here. We have 2 hydrogen. That's why here we have CH2. The second one here, we have also 2 hydrogen. That's why we have 2 hydrogen here. If we go to butene, for example, if we check on the first one, we have 2 hydrogen, which is reflecting here. Then on the second one, we only have a single hydrogen. Why do we have a single hydrogen here? Remember, the bonds of carbons are supposed to balance to be 4. So if we were to count, we have 1, 2, with this one 3, and that one 4. That's why we have a single hydrogen here. Here we have 2 hydrogens, and the last one we have 3 hydrogen. We can also use the same when we are coming up with our skeletal formula. So we have 1 carbon here, 2, 3, but between 1 and 2 carbons we have a double bond. That's why we are showing a double bond there. So the same trend can be followed to explain more about the list of the members of alkenes. So we can use the same trend to explain all members of alkenes. And this one is for this part, and this one in this part, and this one in this part, and you can follow up using the same way. Now we'll go to an example. Usually we have different examples, so we'll use one example just to look at how to check our understanding. So this example we are going to work together. So using a general formula to identify an alkene, we'll use the general formula of an alkene, which is CN H2N. So the question is, an alkene has 5 carbons. Determine the molecular structure, condensed as well as skeletal formula of an alkene. And you should also name the alkene. So the general formula, we'll still use the general formula. Our general formula is CnH2n. But in the question, we have been told that the alkene has 5 carbons. So if it has 5 carbons, we are going to substitute where there is n with 5. Remember, I said n in the general formula represents number of carbons. So if we are to substitute, we're going to put 5 here. We're going to put brackets here and put 5. Then we're going to multiply. We're going to have C5 H10. So if we are to name this one an alkene with 5 carbons, it's pentene. It is pentene. That it means we have answered the question of naming. Now we go to other questions. Structure formula, we are supposed to write 5 carbons. So we have 1, 2, 3, 4, 5. And we're supposed to insert a double bond. So we have a double bond here. So if we insert a double bond, we should be very careful on how we are going to put our hydrogen atoms. So if we have a double bond here, it means the first carbon only needs 2 bonds. That's why we have 2 hydrogen. While this one, since we have 2 here and another one here, it's already having 3 bonds. It means we only have a single hydrogen bond here. While the rest one here we're going to have 2, here we're going to have 2, and here we're going to have 3 hydrogen. So since the double bond is on carbon between carbon 1 and carbon number 2, so we consider composition here to be carbon number 1. So the name must be pent hyphen here. You indicate the position, which is 1 and in. So the name is pent 1 in. That is the name of this alkene. Usually we can also use pentene, but this one is not precise because remember alkenes have a functional group and we are supposed to include the position of the functional group in the name for proper drawing the structure of an alkene. We can write the condensed formula. So for us not to have difficulties in coming up with a condensed formula, we use the structure formula. So this is our structure formula. So when we are coming up with a condensed formula, we only consider the each carbon atom in that molecule. So if we check on carbon number 1, it has 2 hydrogens. So we're going to have CH2. Then we copy the double bond. Put double bond here, and we go to this carbon is only bonded to 1 hydrogen. Then here we have 2 carbon atoms which have 2 hydrogen atoms, so we can simplify it and put it in a bracket like this. The last one has 3 hydrogen. That's why we have CH3 here. So this is a condensed formula. Skeletal formula, we need to consider the skeletal formula. Here we have a double bond. We can use this one. This one only shows the carbon chain, or we can use the bonding lines. So here the first carbon, the second carbon, here we're going to have a double bond between the first and the second carbon atom, here third, fourth, and fifth carbon. Now that marks the end of our presentation on the content based on the success criteria that we were supposed to cover. But in this slide, we have a quick exercise which is known as a buzz session. The aim of the exercise is just to check our understanding based on the concept that we have covered. So the first question is, explain the difference between alkanes and alkenes. Write the condensed formula of the following alkenes. You have the decane, butene, methane. What is the difference between saturated and unsaturated hydrocarbons? Name the following alkenes. Explain briefly why methane does not exist. Name the following compounds. So we have a structure formula here, we have two condensed formula. So if you have done your work, you can compare with our work, which has been also uploaded, the same video. Just compare. First of all, you need to work on your own. From there, you can work. You can compare the results that you have come up with our results, which have been uploaded here with the video. So that marks the end of our presentation. But for many, if you have any question, you can use this WhatsApp, or you can visit us on Xulendo or RG as our website. But if you need references, you can use Excel and Succeed Chemistry Book 2, Achievers Chemistry Book 2, and Target Chemistry Book 2. So for the photos that we have used, these are the links of the photos that we have used. This marks the end of our presentation.